Routers, where do you start, right? You've got small routers, trim routers, medium size, fixed base, plunge routers, 3 1/4 horse. It can get confusing, but it doesn't have to be. Whether you're a seasoned pro or just starting out, in this next couple of videos, there surely will be some information that you can use. I'll be talking about uses of each router or different size routers, pros and cons, and that way you can ultimately make the decision to purchase whatever router or routers that you can use in your own shop. Yeah? Let's get going. All right, let's talk about small routers or trim routers. Now, as the name implies, a small router is going to be used for smallish work, right? Small router bits. Now, back in the day when I did a lot of Formica work, this is the router of choice for flushing up for my overhanging Formica to get it flush with the adjacent edge. And these were ideal. Router like this, you can see these are older Makitas. These new style of Makitas. And by the way, I don't have any cordless routers. I like a cord. That's just me, old school. But this Makita, this is the RT0701C. Fantastic router. Very strong, very well built. A lot of options, a lot of features. Variable speed. Love these routers. Ryobi, here's an old Bosch. This one came as a kit with a lot of different bases and attachments for seaming Formica laminate, all that. This one was designed to go in a corner. Old Rockwell, old, still a good router. Belt driven, kind of weird, right? Anyway, those routers, you're going to use small bits. That just makes sense, yeah? So typically, you're going to have two size collets, here in the States anyway. 1/4 inch collets and 1/2 inch collets. Not collars, but collets. That's the dude that holds the router bit. This is a 1/2 inch, and then, as I mentioned, 1/4 inch. Here's a good example of two bits that are the same size. They're like an 1/8 inch round over. However, the orange one on the right, that's 1/4 inch shank, takes a 1/4 inch collet. The blue one on the left is a 1/2 inch shank, takes a 1/2 inch collet. These smaller routers, they're gonna have a 1/4 inch collet, and that's the limit of that router. So you're gonna have 1/4 inch shanks. Now, occasionally you're going to see a router bit like this, and I'm not even sure why I have this. I think this is silly. You can see how large of a router bit that is. A lot of mass, 1/4 inch shank. That's not a good idea. There is a lot of centrifugal force and inertia, and if this is not chucked up properly, that could be a disaster. Not even sure why I own that. I seldom use it, if ever. Then you're going to have your medium-sized routers, and some of those will be universal. In other words, this router in particular, this is a ported cable. This is model 1001 with a fixed base. I believe you can get a plunge base for it. And this one is awesome because I can use a 1/4 inch collet or a 1/2 inch collet. Very universal, right? These others, I believe, are just 1/4 inch. And then these larger routers, 1/2 inch or 1/4 inch, but I typically only use 1/2 inch bits. And I almost always, when I buy router bits, I try to find a 1/2 inch shank, even if it's a small bit. Case in point, this router bit is a small cove, pretty small, maybe 1/8 inch, but it's a 1/2 inch shank. I could use a 1/4 inch shank with that bit, but here's the thing with a 1/2 inch shank. You're gonna get less vibration, you have more mass. So if I put this router bit in one of these large routers, maybe a little cumbersome to handle, not really. I love large routers because of their mass. They absorb vibration much better, and you just get a smoother cut. Plunge routers are super versatile because you can use them as a regular router, but then you have this plunge capability, right? So if you need to start a cut exactly in a position and then drop the bit down, they're great for template work, all kinds of uses with plunge routers. I have two large ones And then this smaller one, this one's also a ported cable, model number 4514. I love this router. Super smooth, soft start, great plunge router. I believe it has a fixed base, but I just leave this plunge base on it. Fantastic. Great for inlay work, all sorts of things. Here's an older Rockwell with what they call a D handle. And this is very ergonomic. I'm not sure why they don't make these anymore. You can use this all day long and little hand fatigue or less hand fatigue. Fantastic router. That thing's probably 40 years old. And actually my very first router. I bet it's older. It's gotta be 50 years old. I don't even know. Probably don't even make them anymore. This is, well, I know they don't because it's Rockwell. Model 150M, maybe? Now, let's get down to the nuts and bolts of it. What router do you need? Well, I can't answer that. I don't know what kind of work you do. Personally, I love a lot of routers because I have different bits set up in any of them. If I need a 1/4 inch round over, boom, there it is. 3/8 round over, it's that one. If I need a flush trim, it's that one. Laminate work, which I seldom do anymore. It's still set up and ready to go with a 7-degree solid carbide bit. And of course, they're easy to change. I do that all the time. And it depends on what you do. But if I was starting out and I knew I was going to be doing a lot of woodworking or my business was going to be growing, I would probably start with a small, a medium one, and a large one. Maybe a plunge router in a 3 1/4 horse and plunge router in a medium one, and then just a fixed base, either corded or battery powered. Something like that would give you a lot of versatility. I love this dude. This is a fixed base, a lot of horsepower, very strong. This is similar to what I have in, well, that's actually what I have in my router table. So really depends on your work, but you can get by with 3 good routers and tackle a lot of different tasks. You can probably start out with 1 router if you're just starting out. In that case, I would probably start with something medium and then get familiar with that. Now, I don't have any Festool brand. They're pricey, and I'm sure the quality is there, but for the price of one single large router, you could probably buy 3 different sizes. So that's a decision that you need to make. Yeah, the versatility of a router is unmatched. Besides cutting decorative edges or profiles on your pieces, you can trim overhanging materials, route dados, grooves, or rebates, cut circles with jigs or templates. You can cut exterior radiuses of just about any size. This is known as a trammel, and one end will pivot, right? And the router just swings around. Pretty common stuff. I once used a router to create this large interior bulkhead for a commercial job. It was actually a sheriff's department. And out in the parking lot, we had a 41-foot trammel with wheels and all this contraption to cut these parts to make this bulkhead. It came out beautiful, but yeah, router. There's all sorts of, they're good for all sorts of template work. You can do inlay work with a proper collar. And speaking of collars, these are collars, not collets. Collar. So here's a good view of some collars, and you'll notice the one on the lower left, even though it's steel, notice how tall it is. I typically sand mine all down to where I can use all my collars on 1/4 inch material. The one on the right, bottom right, with the red magic marker, that's used for inlay work. This is a special collar for doing inlay work. It's basically a collar with a bushing, and it's 2 pieces. You make one cut. You make one cut for the interior piece, and then you make another cut for the inlay piece, and they fit, they mate perfectly. So it's a good idea to get a set of collars, right? And I like the brass ones rather than the steel ones. I have a set of steel ones I seldom use, if ever. And mostly because if that router bit hits that collar, maybe if you, however it could happen, if it hits the brass, it's not going to be an issue. So get you a good set of collars. Another thing you can do with a good set of collars is make a simple template like this, right? And with this, I can have a collar that fits in here. And then in this case, I use a 5mm bit, and I can punch shelf pin holes all day long, nice and accurate, and even for large cabinets. So this makes quick work rather than drilling if you're not in a commercial shop and don't have a horizontal boring machine that does 27 of them at a time. 54 of them at a time, I should say. Anyway, yeah, lots of versatility. Feed directions with a router. I see a lot of people running a router incorrectly. It can be dangerous, especially at a router table or a shaper, even worse. So if you have a bit buried, in other words, if the bit is within the fence and only a portion is sticking out, this is the proper feed direction, right? Now, I'm going to make 2 passes with this bit, and the first pass, I can go this direction. I should go this direction because there's resistance on both walls that are being cut. Now, a good way to realize which direction the router bit is spinning is just hold your right hand out. You hold your thumb up, that represents your router bit, and your fingers represent the direction of cut. So if you have a handheld router, you would simply rotate your wrist downwards. This again represents the router bit, and of course your fingers are the direction of cut. So you can always tell which way the router bit is going. Typically, you go around a piece of work in a counterclockwise direction. That's the proper cut. If you need to do a climb cut, which you can, you just need to be careful. It can eliminate or mitigate tear out, especially with certain woods that are unruly. You can go clockwise, which is called a climb cut or reverse cut, backwards cut, but then follow up with a conventional direction, the right direction, or counterclockwise. Again, here at the router table, this is a 1/2-inch bit, and it's a pretty big cut for one cut. So I'm going to make that in 2 passes. So I simply just make something like this, some scrap 1/4 inch. My depth of cut is about a 1/2 inch. So I can put one there, one here. That'll hook it, and I'll run that through. Let's give that a go. Push blocks are always a good idea on small pieces. These are fantastic because they have a lot of this, rubber for good gription and a little hook, right? And you can see that worked pretty good. Since there's resistance from both sides of this cutter on the walls of this cut, I can go that direction. Now, if I'm gonna make this groove deeper, I can still go that direction. But if I need to make it wider, now I only have resistance on one side of the wall, and I need to be feeding this way, because if I go that direction, you can see this bit is spinning like this. If I'm on that side of the cut, it will want to grab the work and propel it right through. So direction of cut is really important. So here I'm just simply making the cut deeper, right? So the direction that I'm moving the board across the fence can be the same. And now I'm going to go the other direction because I'm going to make the cut wider. And so the bit is cutting into the work. You can actually hear it. It sounds normal. Boom, I ended up cutting that push block just a bit, but that's how they're designed, right? So that's a safe direction to cut when the bit is away from the fence. Although if I was cutting the other wall of that groove, I would be moving the board from right to left. Hope that makes sense. So I'm cutting some grooves to accommodate some of this T-track, right? And I could have used a dado blade, but sometimes a router bit is quicker, faster, and I like showing options. So this T-track, you can see how good that fits. This T-track is a tad under 3/4 of an inch. So what I decided to do was use a 1/2 inch bit and make a couple of passes. And rather than making one groove and then moving the fence, I just utilize a spacer to make up that difference. This is a little under 3/4, so a 1/2 inch bit, and then a little under 1/4. Seems to fit just right. All right, I'm going to show this again because it's really important. Feed direction, the direction the board is moving in relation to the direction that the router bit is spinning. Here you can see this would be the normal direction of cut if the router bit was buried within the fence, or if I'm utilizing the full diameter of the router bit. It's all about resistance. And again, I'm just making the cut deeper so I can go the same direction. Okay, remember when you hold your right hand out and your thumb represents the router bit and your fingers represent the direction of the spin. In this case, it's spinning counterclockwise. Watch where the bit exits the edge of this board. Right there. You can see that there's resistance as the cutter is making the cut because it's cutting into the work. All right, I realize this is crazy redundant, but it is so important. See where I put that arrow? That's the wall I'm going to be cutting. And so I can feed from right to left. If it was the other wall closest to the fence, I would be going the other direction. So just keep that in mind as you're making your cuts with the router or at a router table. Yeah. All right, so here's a bit of a diagram of the conventional direction that you would go when you're using a router. You're always going to be going counterclockwise around the workpiece. So here's the router, and I had showed you this before. You hold your right hand up, out, and your thumb represents the router bit, and your fingers represent the direction of the router bit spinning. So in this case, it's going to be cutting like this. We can look at the router bit and see that the cutters would in fact be cutting into the work, right? Turn my hand over because it's handheld. So you can see that this is the direction of the spinning router bit, and it's cutting into the work as we move around the piece, right? However, there are times that you want to go the opposite direction, and case in point, plywood is notorious for splintering out, especially on cross grain. So let's make this cut. I'm going to run the conventional direction and see what it does. Plug this in. I don't know how well that shows up on camera, but you can see it's just a little bit rough, a little bit splintered out. So let's run a climb cut or a reverse cut now. So it's a lot cleaner. It probably doesn't show up on camera very well, and truthfully speaking, it didn't splinter out near as bad as I thought it would. I'm routing these jigs that I'm working on, and if I ran the conventional direction, this cross grain would inevitably splinter out. So I go backwards and make those reverse cuts. Now here's something interesting to note. If you're going around a piece, you're always going to be going counterclockwise, but don't get caught up in that direction, the counterclockwise. You're literally moving the router bit in this direction in relation to this edge. So if I take a circle and we have an edge here, we're going that direction. Here's that same edge, we're going that direction. Well, now it appears as we're going clockwise, which we are, but we're still going the same direction in relation to the edge. So don't get caught up in clockwise, counterclockwise. This is the direction in relation to the edge that you're always going, whether you're going on the outside of a piece or on the inside of a piece.
Incidentally, the smaller the router bit, the safer it is to make climb cuts. Here I'm going the conventional way, just so I can show you in the next still frame. It'll show how chipped that edge is. I did a little chamfer cut. You can see how chipped it is, right? Then I went on another board with a climb cut, and look how smooth that is. So it does make a difference. Thanks a ton for watching. Come back for part 2. Ciao.